All right, so systems of equations, if we wanted to come up with some kind of definition, so to speak, for that, a system of equations is a set of two or more equations that contain two or more variables. So the solution that you get to a system of equations is a set of values that make all equations in that system true. So when you're graphing systems of equations, if the lines intersect at a point, that means that you have one solution. So if they intersect at a point, right, they both, or they cross. All right, so that's one type. If your lines are parallel, what happens when lines are parallel to each other? Are they ever going to cross? No. So how many solutions do you think that they have?
Infinite.
They never cross.
None.
No solution. And what if the lines are the same line? Infinite. So if they intersect, you have one solution. If they're parallel, you have no solutions. If they're the same line, you have infinite. So here's where I said it comes in handy to label your lines so you know which line is which.
Yeah. I think it'd be easier if you could like name the equations like A, B, C, D, E, and then put A, B, instead of all the stuff.
Yeah, that would be easier. Or if you did it like different colors.
Yeah.
All right, so let's take a look at this first one. We're going to graph each equation separately. Okay, so we're not going to try to graph them all at the same time. We're going to graph one at a time. Let's start with this first one. How do I start graphing this? Negative 4 on the y-intercept. Okay, so I'm going to start right here at negative 4 on my y-intercept. What's my slope? Huh? 2/3. So my change of y is 2. 1, 2. My change of x is 3. 1, 2, 3. Both are increasing, or you can decrease and decrease. 1, 2. 1, 2, 3. 1, 2, 1, 2, 3. So I'm going to connect those dots and make myself a nice little line. So now I'm going to label what this line is. Alright, so I've graphed it, labeled it. So I've grabbed this line. I'm going to put a little check mark so I can say, okay, I've done that. So now let's graph our second line. What's our y-intercept? Where are we starting?
3.
3. And what's our slope? Negative 1/2. So if I increase by 1 on my y-axis, I need to decrease by 2 on my x. But what if I decrease by 1 on my y-axis? Then I increase by 2. Cool. So decrease, increase, decrease, increase, decrease, increase. Okay. Connect those dots. Label it. Did these lines cross?
Yeah.
Did. At what point did they cross? 6, 0. So the solution to this should be the coordinate 6, 0. Now it's always a good idea to check your work. If the solution to this system of equations is 6, 0, that means that for both of these equations, if I substitute y for 0 and x for 6, I should get a true statement, right? Because a solution to a system of equations is a set of values that makes all those equations true. So let's check it. I'm going to substitute 0 in for y and 6 in for x. And I'm going to do the same for my second equation. All right, 2/3 times 6. 2 times 6 is 12. 12 divided by 3 is 4. And 4 minus 4 is 0. Does 0 equal 0?
Yes.
Okay, that's true. Sweet. All right. What is 1/2 of 6? 3. And since it's negative 1/2 times 6, it's going to be a negative 3. And negative 3 plus 3 is 0. So does 0 still equal 0? Yes, so that means that this solution satisfies both equations. So am I confident in my answer? Yes. I am confident.
I thought we were pre-math.
Okay. You were last year. All right, let's look at this second one down here. What's the first equation? Y equals 1/2 x minus 1. And what's the second equation? Y equals x minus 3. All right, let's graph this first one. Where am I starting? Negative 1. And what's my slope? 1/2. Positive, right? So I can increase and increase or decrease and decrease. So I'm going to increase by 1 on my y-axis, increase by 2 on my x. Increase by 1 on my y, increase by 2 on my x. Increase by 1 on my y, increase by 2 on my x. I can also decrease by 1, decrease by 2. Decrease by 1, decrease by 2. Okay. What's up? What's up, Ryland? What'd you say? Because what? Right, but it's okay to decrease and decrease, right? Because 2 negatives make a positive, so that I'm still okay to do that. And then label it. All right, so let's graph our second one. What's our y-intercept here? Negative 3. And what's my slope? 1. Positive, right? Increase by 1, increase by 1. Increase by 1, increase by 1. Increase by 1, increase by 1. Increase by 1, increase by 1.
Everything's like slow motion from when you do it. Like, it happens.
All right. We have a solution, right? They intersect somewhere. Where do they intersect? At what point do those two lines cross? Kayla? I'm not going to agree with that. Clay? You have it on your paper too. 4, 1, right? Go over 4 and up 1. Ordered pairs are always written X, Y. What should I do to make sure that I'm correct? Check it. So I'm going to plug in 1 for Y and 4 for X. What's 1/2 of 4? 2. And what's 2 minus 1? Is this a true statement? Sweet. What's 4 minus 3? 1. Is this a true statement? Am I confident in my answer choice then? Yes. So let me ask you a question. Now that we've done 2 of these, what makes these equations a system of equations? What makes them a system? Think about at the beginning of class, we took a definition of what a system of equation is. Luke?
Because there are 2 or more equations. There are 2 equations, and each one has 2 variables.
Right? Each one has an X and a Y. Each one has something that we don't know the value of for yet. How you feel?
Good.
All we're doing is graphing, right? Graphing, figure out where they cross, if they cross. Sweet. All right, flippy flip over onto your next page. Just because I want to be able to glue both of these in on one page, that's not going to work out well. Never mind. I'll just take another page, no big deal. All right, so take this one that has the 3 graphs.
When do we start doing math?
This is the start of it.
Oh.
No, you still do this in 8th grade, but we do more with it in math 1. We did math 1 stuff at the beginning of the year.
We did.
Mm-hmm.
What was
Simplifying radicals. I won't do that in 8th grade.
I need to go back to the other class. I was like, we're doing the same thing. We are, right?
All right, what I want you to do is I want you to graph and figure out what the solutions are to these 3 problems, and then check your work to make sure that your solution is correct. We'll come back together and make sure everybody's on the same page. Okay? And you can work with the people in your group for assistance.